Hey math kids, today we're going to talk about the laws of logarithms. And so if we have log m plus log n, what we do is we actually multiply those two pieces together. So we get log of mn. So the important thing is that the logs have the same base. In this example, it's a base 10, but it can be any base as long as they are the same. Okay, so if we have log m minus log n, you may be able to guess that since addition was multiplication, subtraction is division. Okay, now this next one is really strange, but really useful. So m log b goes to log of b raised to the m. So basically what happens in this one, this m can jump up and become an exponent on this b. You can also go the other way. Sometimes that's helpful. So if you have an exponent right here, you can take it out in front. Once again, these are all written as log base 10s, but they could be log base anything just as long as both of them have the same base. Cool. All right, so let's use these on a few examples. So we have log 5 plus log 3. So the rule for addition, first we check, do they have the same base? Yes. And so we write a log that has that same base. And then addition becomes multiplication. And so it is log 15. Okay, now we have log base 3, 24, minus log base 3, 8. So we check, they both have the same base. So we rewrite that log with that same base. And then 24 minus 8 becomes 24 divided by 8. And so the final answer on that one is going to be log base 3, 3. But we have that special property of logs where log base 3 and 3, and there would be a little exponent of 1. So this answer is actually just 1. Okay. Now we have log base 2, 5, minus 1. This doesn't even look like a log problem, so we have to think outside the box a little bit. And we need to change this 1 into a special one. And so I'm going to rewrite this. So we still have our log base 2 of 5. Now we know we want a log base 2. So we're going to say log base 2. But how do we make that equal to 1? Well, it's kind of like this situation, right? So it's log 3, 3. So it's going to be log 2, 2. Now, since we have log 2, our final answer is going to have a log 2 in it. And then 5 minus 2 is really 5 over 2, because subtraction with logs creates division. And this is our final answer. Okay, let's keep going. So now we have 2 log 7 minus 3 log 2. So the first thing we want to check is that we have the same base, which we do. It's log base 10, log base 10. And we're going to use that exponential rule where we bring that up here. So it's going to be log 7 squared minus log 2 cubed. Okay, so let's actually square it. So log 49 and log 8. Okay, subtraction means we're going to get log and then division. And so that's going to be our final answer. Okay, now we have 2 log 3 plus 3. Once again, we're going to have to do something special with this 3. So we have 2 log 3 still. But this is going to be 3, and then we want like a special 1 and with the same base as this. So we're going to say log 10 because that's like a log base 10, 10. And we could cancel these and we get back to 3. Alright, at this point it's very similar to the previous problem. Bring those up there, so we get log 3 squared, and then log 10 to the 3. Okay, let's actually square that, so log 9, and actually apply the cube, so log 1000, and then we want to multiply these, so we do log 9000. Okay. Keep going. Okay, now we have log 8 over log 4. So what we're going to want to do on this one, we're going to want to write these using the same base, if at all possible. And 8 and 4 can be written using the same base. So we can do log 2 to the 3 and log 2 squared. And then we can take out those exponents, doing the reverse of what we've done on the last 2 problems. So we write that as 3 log 2 and 2 log 2. Well, since these are just multiplication, log 2 cancels log 2. And so the final answer is going to be 3 halves. Alright, we have 2 more examples. So we have log of 1/9 equals -2 log 3. And so the goal is to show that these are equal. So what you're going to do is you're just going to choose one side and make it look like the other side. So I'm going to choose the left side. And we see there's a 3 right here, so I'm going to start by doing 1 over 3 squared. Okay, and then I'm going to bring that to the top, and so that's going to give me log 3 to the -2. Then I'm going to use that exponent rule where I can bring that out there. So I get -2 log 3, which is the same thing as this. And so I just proved that those two are equal. And the last one, we need to prove that log 500 is equal to 3 minus log 2. So this one's a little complicated. I think I'm going to start from this side and see what happens. So I want to get a log base 10, and so I'm going to turn this into a log base 10. And so I'm going to say log 10 times it by 3, and then keep my log 10 2 right there. And then after this, I want to somehow combine my logs, so I'm going to bring the exponent over here. So log 10 to the 3 minus log 2. So that's 1,000. So I'm going to say log 1,000 minus log 2. Our exponent rules say that we're going to do 1,000 divided by 2. So log 1,000 over 2, which is log 500, which is what I needed to prove. So if you need additional help, please come to Math Lab. Until then, calculator.